Good morning, students. We are in third year, fifth semester. The subject what we are going to learn now is AD 3501 Deep Learning, presented by Dr.R.Mekala, Professor, Department of Artificial Intelligence and Data Science. The course objective of deep learning is understand the need and principles of deep neural networks, realize the convolution neural network and recurrent neural network architectures of deep neural networks, comprehend advanced deep learning models, and finally learn the evaluation metrics of deep learning models. At the end of the course, the students will be able to explain the basics in deep neural networks, apply convolution neural network for image processing, apply recurrent neural network and its variants for text analysis, and apply model evaluation for various applications, and apply encoders and generative AI models for suitable applications. These 5 are the course outcomes. The textbook for this particular subject is Ion Goodfellows. The title is Deep Learning. The second is Andrew. The title is Deep Learning, a Visual Approach. The 5 units of the subjects are Unit 1, Deep Network Basics. Unit 2, Convolutional Neural Networks. Unit 3, Recurrent Neural Networks. Unit 4, Model Evaluation. Unit 5, Autoencoders and Generative Models. Now let's start with Unit 1. Unit 1 is all about Deep Network Basics, in which we are supposed to learn linear algebra, probability distribution, gradient based optimization techniques, machine learning basics, challenges that are motivating deep learning and deep networks. Before entering into the subject, let's see the mapping between course outcomes and POs. The first unit CO is students will be able to explain the basics in deep neural networks. The POs that are aligned with this are PO1, which is nothing but engineering knowledge, which is highly related. PO2 is problem analysis, which is moderately or mediumly related. PO3 is design and development, which is also moderately related. And we don't have any mapping between PO4, 5, 6, 7, 8, 9, 10 with the CO. PO11, which is project management and finance, is lowly mapped with the CO. Next is going to be lifelong learning, PO12. That is also lowly related with this CO. And PSO2 that is related with this is going to be domain skills, which is lowly related. PSON is also domain skills, that is moderately related to this CO. This is what the course outcome versus program outcome mapping for this first unit. Let's see what is machine learning, or recollect what is machine learning, what you have learned in the last semester before entering into the deep learning. Okay? Machine learning is nothing but a branch of artificial intelligence that develops algorithms by learning the hidden patterns of the data sets used to make predictions on new similar type of data without being explicitly programmed for each and every task. It can also be set as a form of applied statistics with increased emphasis on the use of computers to statistically estimate complicated functions and a decreased emphasis on proving confidence intervals around these functions. So, you might have learned AI in the second year third semester and machine learning in the second year fourth semester. Those two subjects are going to be the basic for this deep learning subjects. Let's see what is the life cycle of machine learning. First step is you are supposed to study the problem. After studying the problem, you have to proceed with collection of data. Once the data is collected, you have to proceed with model selection. Let's see what is model in the forthcoming slides. After selecting a model, you have to build the model and use the data what you have collected in the second step to train the model. Once you build and train the model, you have to evaluate and see whether the model works correctly. If it is not, you have to tune the model according to your requirement. After tuning it to your requirement, the next step is going to be deployment of the model. Once you deploy it to the end user, the next step is going to be monitoring the usage of that and maintaining the model what you have delivered to them. This is what the machine learning life cycle is. I said in the next slides you will be seeing about the models of machine learning. As you know that there are two types of machine learning: supervised machine learning, unsupervised machine learning, reinforcement machine learning. Okay. What do you mean by supervised machine learning? It's a model wherein you have to train the data with labels. You can only train the labeled data with this supervised learning. The labeling has been done in two ways. One is with classification, the second one is with regression. And in unsupervised learning, the models are getting trained using unlabeled data. Only the data are getting grouped called clusters, and they have been trained using this learning algorithms. The third type of machine learning is reinforcement learning, whereas the model take actions in the environment, then receive the states, updations, and gets the feedback, giving it to the environment and working towards the betterment. This is what about types of machine learning is. So this is going to act as a input for deep learning, what you are going to learn in this semester. Let's see what is deep learning. Deep learning is a subset of machine learning, or you can say it is a special kind of machine learning which is working technically in the same way as machine learning but with different capabilities and approaches. The deep learning models are capable enough to focus on the accurate features by requiring a little guidance from the programmer. These deep learning models can be implemented with the help of neural networks. The idea is it is motivated by the concept of biological neurons, which are nothing but the brain cells what we are having. So this is what the basics for deep learning. Okay, the deep learning basics is nothing but the brain cell neurons replications. You can say it like that. And how the deep learning works is, it takes the image as an input and feeds it directly to the algorithms without requiring any manual feature extraction. Okay, the images are getting passed to different layers of the artificial neural networks and predicts the final output. For example, you see this diagram where you have your deep learning model, the input is given and the output is obtained. So the input is given as an image, I am giving as a car. Okay, the result would be either it's a car or not car. The deep learning works or gets an image as the input and feeds it directly to the algorithm, deep learning algorithm, and the output is obtained whether what we have got is what we require or not. This is how deep learning works. And the deep learning models are convolution neural network, recurrent neural network, autoencoders, and classical neural networks. These are the some popular deep learning models. In second and third units, we will be learning about CNN and RNN, and in fourth unit, we will be learning about autoencoders, and finally, we will go with generative AI, right? And the applications which can be mentioned here are self-driving cars, voice control assistants, automatic image caption generation, and automatic machine translation. These are all the well-known applications of deep learning. And what are the challenges that are motivating this deep learning are complexity of the concepts, overfitting and generalization, resource intensiveness, rapid evolvement in the field, lack of practical applications that are existing, debugging challenges, data dependency, bias and ethics, collaborative skills that are needed. These 9 are the main challenges that motivated us to move towards deep learning from machine learning. Okay. So what do you mean by complexity of concepts? The underlying mathematics and algorithms can be difficult to grasp, understand, work out, and finally implement. Okay, this discourages the learners to move towards this deep learning. Okay, and what do you mean by overfitting and generalization? Which is nothing but understanding the concept of preventing the overfitting and ensuring the model that requires practical experience for its implementation. Okay, overfitting means the model may work for trained data, but when you try to apply for similar environments, it may not work. Okay, so we have to create a model in such a way that it is not overfitting as well as underfitting. You have to go with generalization models. Third challenge is resource intensiveness. As you all know that it demands significant computational resources that makes a barrier in moving towards the deep learning. And the field is getting evolved second by second, minute by minute. So that is also going to be the huge challenge that is going to be a barrier. Okay, and there are no good practical applications in real world, which is making harder to stay engaged in this field. And debugging is also time consuming, that frustrates the users. Okay, so that is also a main challenge, and data dependency is the very big challenge, because the necessity of large high quality data sets are a hurdle for learners to niche in this area. And you know that there should be an ethic. Understanding and addressing those ethics are, and data models are crucial to go with this deep learning. And if you want to work with this, you need a big data which has been given to you in a proper manner. So collaborative skill is mandatory to move with this deep learning. This is what all about deep learning introduction is. We'll see in further classes. Thank you.